Hello everyone and welcome to the Math Bender. I am Adnan Zedi and this is the first session on permutations and combinations. Let's start off. Okay, so let's say if I write 5 times, 4 times, 3 times, 2 times, 1. We'll multiply it and we'll give you the answer. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120 times 1 is 120. And the same way, if I write 4 times 3 times 2 times 1, you'll get a certain answer. But the problem arises when you have to write 10 times, 9 times, 8 times, and so on, because it's going to consume more time. So we come up with a terminology, we call it factorials. What factorials? We represent it like this with an exclamation mark. It means when I write 5 factorial, so it's understood that it is 5 times, 4 times, 3 times, 2 times, 1. You can manipulate it in other way, we'll see in future questions to come. But anything that you write with a factorial means that one term, the first term, after that, one less than that, and so on. It multiplies. So let's see if we have questions like these. If someone says, what is 7 factorial? So it's understood that it's going to be 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1. And if you want to find it out using your calculators, so let's say if I write 7 here, and as you could see the x to the power -1 sign, press shift and press this button. I'll show again. 7, press shift. Everything with the yellow color is responding to the shift button. So press this button again and it gives you a straight away answer, although the question clearly mentions that you're not supposed to take calculators, but we're just solving it for the sake of the video. So 5040. So let's say how we can manipulate multiple other questions and see. So 7 factorial over 3 factorial. So as you could see here, 7 factorial times 6 times 5 times, I can write this as 4 factorial, because 4 factorial is 4 times 3 times 2 times 1. So rather, I can write it like that too. So if I have to cancel this 3 factorial, so what I could do is I could expand it up till 7 times, 6 times, 5 times, 4 times 3 factorial over 3 factorial, and this cancels out. Hence, what the answer is going to be 7 times, 6 times, 5 times 4. So 7 times, 6 times, 5 times 4. Again, if you want to use your calculator for this one, so 7 factorial, you write it like this, over 3 factorial. And you get your answer as 840. You may use any question. For example, I'll solve the last one. So 5 factorial over 3 factorial times 7 factorial over 4 factorial. Now, as you could, 5 times 4 times 3 factorial, if I've just made up my mind to cancel that 3 factorial with the upper one, and 7 times 6 times 5 times 4 factorial, I'm cancelling this one with the other one, and hence you can cancel these out. The answer is going to be 7 times 6 times 5 times 5 times 4, whatever that you get after that. So as you could see, if you try to make some sense out of it, you'll see that the first term, if let's say is 7, the next term is 6, the next term is 5, the next term is 4, and so on. So the next term, every next term is 1 less than the previous term. So if I say the first one is n Then if I write n factorial, so I can write this as n times n minus 1 times n minus 2 and so on. It never ends. So the same way, if we have a question like this, n plus 2 factorial over n factorial. So how would you approach it? So the first thing is you write n plus 2 times 1 less than n plus 2 is n plus 1, and 1 less than n plus 1 is n. And you would leave your answer with a factorial sign up till here because you can clearly cancel these two out. So the answer to this one is n plus 2 times n plus 1. Similarly, if I have a question like 2n plus 1 over 2n minus 1 factorial. So what I could do here is 2n plus 1 times with 1 subtracting from 2n plus 1 will be 2n times with 2n minus 1 factorial. I'll, I'll leave it up till here because I could see that 2n minus 1 factorial is as denominator and I can cancel them out. So the final answer will be 2n times 2n plus 1. Let's move on to some where we can apply them. And this is where permutation and combinations start. Just a brief idea, permutations and combinations are everywhere in your life, wherever you use your identity card number. So the more numbers are there on your identity card or passport or any other travel or any other document that you have, the more the numbers are there, more possibility for for the sample space that they can cater to. So how do we find out all the possible ways? So let's say if we have 1, 2, 3, and I want to find out all the possible ways I can arrange these three numbers. What I could do is 1, 3, 2, then 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. There's no other way I could have apart from these. But the problem comes if I give you a question like 1, 2, 3, 4, 5, 6. There will be too many possibilities and there is a chance of error as well. So the best way is to decipher how to find out the permutations, or if you could generate what is the logic behind it. So if we have a three-letter word or a three numbers, so if you notice in the first digit there are 1, 2, and 3. There were three letters, three numbers. And for every that first digit that comes here, then there are remaining two of the numbers that fills here. And then if one digit comes here as well, then there is only one digit remaining. So there are possible 6 ways we can arrange them. And now, if you try to recall 3 times 2 times 1 is as same as 3 factorial. So this is how we apply factorials in these scenarios. So let's say if a question is A, B, C. So there are three letters, and what you can do is in the first digit, in the first place, there's a possibility of the three letters. If one letter takes the place of the first as the first letter, then there are two letters remaining which will fill here and then 1. So the same as 3 factorial. So let's say if we try to see how many possible ways can we arrange this. So what we do is we just count them 1, 2, 3, 4, 5, and we can write straight away as 5 factorial, which is equals to 120 as I remember. HIRE. I would want you guys to pause the video and try finding how many possible ways we can arrange this word. So it's going to be 4 factorial. Okay, so let's see when there's a repetition involved. So if I write a word E, 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 the problem here is that if we try factorial, so factorial is for shuffling. So what it does is it takes all these three E's as different entities. If we had written it as E1, E2, E3, now they are different, but if you see them, they're all same. So how many possible ways can you arrange them? That's it. This is just the one possible way, because you take this E over here or this E over there, it is as same as what we see right now. So when there's a repetition involved, so what you do is you count the letters that are being repeated. For example, in this situation, I see E is being repeated 3 times. So what I do is I write 3 factorial over the letters that are being repeated. 3 factorial, which gives you 1. For example, A, B. So there are 3 letters as you see. You write this as 3 factorials over. Now A is being repeated 2 times. You write this as 2 factorial. So which gives you 3. You can try looking at it. A, B, A, B, A, A. That is it. So let's say if we have a word like this. S, T, A, T, I, S, T, I, C, S. Statistics. So let's see if we have a word like this, statistics. As we could see that T is repeated 3 times, I is repeated 2 times, and S is also repeated 3 times. So, and there are how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So write 10 factorial over 3 factorial for T, 2 factorial for I, and 3 factorial for S. All you have to do is write 10 factorial over 3 factorial times 2 factorial times 3 factorial. And it gives you straight away the answer as 50400. So there are 50400 ways you can arrange the word statistics without any restriction. So this is just the basic lecture on permutations and combination. In our second session, we'll talk about cases where there are restrictions involved. All of these were without restrictions, and in our next session, we'll discuss those cases and how to cater to those cases. Until then, take care. Bye.